Centaurus, shaping the future of cloud-native infrastructure in the age of AI, 5G and Edge. As cloud becomes the norm to develop and run current and future applications such as AI and 5G, current cloud infrastructure technologies need to continuously evolve to meet new challenges and requirements. Today, some challenges we need to address as cloud adoption continue to grow exponentially is: cloud infrastructure platform needs to manage larger and larger scale of compute and network resources across data centers, and faster provisioning of these resources. In addition, cloud infrastructure also needs to support more and more types of resources or workload. It needs to unify the management of various resource and workload types, such as bare metal, VM, container and serverless. This will help to reduce management cost and simplify overall operations for cloud providers. At the same time, with the new generation of AI and 5G application, it requires low latency and data privacy. Edge computing is becoming a part of the cloud. Therefore, the cloud infrastructure technologies need to be redesigned and optimized to manage constrained resources and applications running at edge nodes that are closer to customers and customer data. Sometimes we call it distributed cloud. With distributed cloud, one of the challenges is being able to intelligently schedule and place work nodes among the hyperscale data center or the edge site. So the new type of cloud infrastructure platform needs to support intelligent scheduling and location-aware resource and workload scheduling between data center and edge cloud, in order to improve customer experience with low latency and high throughput. Cloud native is becoming a norm for developing and managing modern distributed software system. Cloud infrastructure platforms need to take the cloud native architecture and design approach for better scalability and extensibility. Today, we are announcing an exciting open source project, Centaurus, to meet those challenges we stated previously. Centaurus is a unified large-scale distributed cloud infrastructure platform. Our goal is to provide a new infrastructure platform, in a more cloud-native way, for any enterprise or company, to build scalable and unified infrastructure for their public or private cloud. Centaurus consists of two sub-projects, namely Arctos and Mazar. Arctos is the compute sub-project managing clusters of compute nodes and provisioning VM, containers and other types of workloads on demand. Mazar is the networking sub-project that manages and provisions virtual networks and communications between workloads in a scalable and high-performant manner. This is the high-level vision and architecture of Centaurus. This cloud-native architecture offers capability to manage resource both at data center and constrained edge site. It's a truly distributed cloud platform. Centaurus is designed from the beginning for large-scale regional deployment. Every component in this architecture can be partitioned for scalability. We aim to support 300,000 compute nodes and millions of network endpoints in a region. Centaurus leverages de facto industry standards such as CRI, CSI and CNI, to provide easy integration with external systems such as Kata container, cloud storage and other cloud network components. As mentioned earlier, Arctos is the sub-project under Centaurus for compute management and workload orchestration platform. It's derived from well-known Kubernetes architecture with major changes and redesigns. First of the major changes is change for partitioning and scalability. We have added partitioning capabilities into major components of Kubernetes architecture. In Arctos, API server, etcd store, controller and scheduler can be partitioned to achieve large-scale deployment. Arctos introduces a true and hard multi-tenancy design into Kubernetes, and makes Kubernetes a real multi-tenant platform. This enables multi-organizations to safely and easily share a same physical cluster infrastructure. Arctos unifies VM and container into one, so that platform manages VM the same way as managing containers. It also offers the same API user experience. Arctos introduces new network objects and corresponding operators. This is part of the multi-tenancy model, so that containers or VMs are created within subnet or VPC. And they are naturally isolated. Arctos incorporates edge capabilities into the platform, so that Arctos can manage compute nodes at edge site and orchestrate applications running at resource-constrained edge. Arctos supports in-place pod vertical scaling. User or VPA specifies desired resources by patching the resources requests and limits of containers or VM. This allows resizing resources allocated to a container or VM pod without restarting them. To quickly summarize, Arctos is a new type of cloud compute infrastructure that provides application-oriented primitives to manage workloads and resources. Optimized design from cluster scalability to regional control plane. Built-in multi-tenancy with strict tenancy isolation and flexible cross-tenant management. Single control plane for containers and VMs, as well as unified resource pool and consistent API experiences. Also manages edge nodes and orchestrate workloads with intelligent cloud edge scheduling. The second sub-project of Centaurus is Mazar. Mazar is the networking project powered by the Express Data Path and GNeed protocol for high-scale cloud. Mazar is a simple and efficient solution that lets you create a multi-tenant overlay network of a massive number of endpoints with extensible network functions. There are two components to Mazar, the data plane and the management plane. Mazar's data plane provides high performance and extensible packet processing pipeline and functions that achieve Mazar's functional, scale, and performance goals. Mazar's management plane is built for data plane programming and routing scalability. As mentioned, Mazar's data plane is powered by XDP technologies and GNeed network protocol. Mazar data plane leverages natural partitioning of a cloud network such as VPC and subnet for fast and large-scale network endpoint provisioning for tenant VMs and containers. It introduces new abstract components called bouncers and dividers. Bouncer is responsible for packet forwarding and routing within the network. Divider is responsible for packet forwarding and routing between the network and VPC. Bouncers and dividers are in network and horizontally scalable hash tables. The management plane populates the bouncers and dividers tables according to network domain partitioning. Mazar's management plane is built on top of Kubernetes architecture using CRD and operators for data plane programming and routing scalability. This makes Mazar's management plane a cloud-native platform that can scale to manage large scale of virtual networks and endpoints. Specifically, Mazar introduces VPC and subnet network objects and operators to create and manage VPC and subnet for tenants. Tenants manages their applications within their VPC or subnet. Mazar also introduces bouncer and divider network objects and operators to scale and manage package routing within a network and between networks. Mazar's visions and goals are: support provisioning and management of large number of endpoints, achieve high network throughput and low latency resource provisioning for dynamic cloud environments, create an extensible cloud network of pluggable network functions, and unify the network data plane for VMs, containers, serverless functions, and other virtualization technologies. Thank you for watching. Above is the high-level introduction of Project Centaurus. For more detailed information regarding Centaurus, please visit our GitHub pages. Please also visit our video playlist for more detailed demo videos. Thank you.